Hello everybody and welcome back. We are on Unit 4, Lesson number 1, so we are starting a brand new unit today. We are going to be going over water. So in earth science there's kind of two different units of water that we talk about. The first is in relation to, surface water, groundwater, human drinking water, what we think about as mostly fresh water, and then we also have a unit on oceans. So we're going to talk about kind of focusing on freshwater first, and then we'll move into oceans for our next unit. So as always, you should have downloaded your interactive notebook pages for the day. We are on a new notebook, and I will just go ahead and make the caveat here that Unit 4 is long. It's the longest unit we've done so far. It'll take us about 12 days. So this will also be your largest notebook. So please do not wait until the last minute to do this notebook. You should be completing these pages daily and then organizing it as we go along. That's just the easiest way to keep up with it, and that way it won't drive you crazy in the end. So let's go ahead and jump into our notes today. So in order to talk about the water cycle, we need to talk about something called the hydrosphere. And the hydrosphere is one of those spheres that we talked about on one of our very first lessons when we did the branches of earth science. So the water on and in Earth's crust makes up the hydrosphere. So the hydrosphere is just all the water on the Earth. About 97% is contained in the oceans, which is most of the water. And then the water contained by land masses makes up only 3%. So the fresh water that we have that's accessible only makes up about 3% of all of our water. So of all the fresh water, more than 70% is in the form of polar ice caps and glaciers. So it's frozen. So we can't actually access that. So all the water that we have for human consumption, and when we think about all the things we use water for, it's less than 3% of the water on Earth. So most of the remaining fresh water is groundwater, which is what we'll be focusing on really mostly tomorrow, but today and tomorrow. So the water cycle is basically just how all the water on Earth is recycled. So it's recycled in a continuous process, and there are some parts other than evaporation, condensation, and precipitation. So we're going to be talking about what happens once water reaches the Earth. Now the water cycle should be a review from middle school, but just to review really quick, we can follow the arrows kind of like in our rock cycle. We can kind of follow the processes of what's happening. So precipitation will fall as rain, then we'll get infiltration into the ground and percolation, and that's just where the water is absorbed into the ground. Some of the water will run off, so stay on the surface and run off and make it to rivers, oceans, and lakes. And then there is evaporation, where water is evaporated from larger water sources. And there's also transpiration, where plants will release water as well. And then eventually we will get condensation, which will form clouds, which will then lead to precipitation. So we go in this one big cycle, and that's just the process of how the water is recycled in our environment. So step one of the water cycle is evaporation and precipitation. So the evaporation of the water will introduce water into the atmosphere in the form of invisible water vapor and visible clouds through a process called condensation. So condensation is the formation of the clouds, and basically it's just the creation of clouds through water vapor. Then the clouds will return the water to the ground below through rain or precipitation. So once the clouds get too heavy, and we'll talk about all of that when we get to our weather unit, but when the clouds basically get too heavy and oversaturated, the precipitation will fall to the ground, and then it will either run off into the lakes and the streams, or it will infiltrate into the ground in the bottom and also percolate into groundwater. So this says step 1.5 because it is a part of the water cycle, but transpiration is the release of water vapor from plants. So it's really similar to the way people sweat. So this is not evaporation. This is not radiation hitting the plant and the water is evaporating off. It's actually a release from the plant itself. So we can think of it almost as the plant is sweating. So the water vapor is included with evaporation, and then the whole process is called evapotranspiration. So we've got our evaporation and we have our transpiration, and they kind of combine in the atmosphere to condensate into our clouds. So let's talk about surface water and surface water movement. So today we're going to be focusing specifically on surface water, which will be water that is above ground. Okay, so water above ground. So we basically get surface water from runoff. So that's basically when it rains, instead of infiltrating into the ground and then going into the ground, we have it running into other waterways. So they may run into a stream, a river, or a lake. It could evaporate back into the atmosphere, or it could accumulate as puddles and eventually seep into the ground and become groundwater. But as long as it's in the puddle, it is still considered surface water. So there are a few conditions we need to know about that will determine whether water will seep into the ground or become runoff. So vegetation, rate of precipitation, soil composition, and slope. So vegetation, if there's more grass or other vegetation, that means more water will enter the ground. Precipitation falling on the vegetation will allow water to move slowly from plants to the ground. So anytime you have more of a slow movement of the water, it will be more likely to seep into the ground and become groundwater versus surface water. So precipitation falling on barren land causes clumping, which causes closing of pores and less water entering the ground. So if you have absolutely no vegetation whatsoever, what will happen is an area will become kind of almost flooded. So if it gets too much precipitation at once, the soil and the particles in the soil will clump together and prevent the water from infiltrating into the ground and becoming groundwater. Also, the rate of precipitation will determine whether something seeps into the ground or runs off. So light precipitation tends to soak into the ground. So light, steady rain will infiltrate the ground. During heavy precipitation, however, water falls too quickly to soak into the ground and it becomes runoff. So runoff comes from very high, heavy precipitation. Soil composition also determines whether or not we will get surface runoff. So soil with a high percentage of coarse particles, so larger particles like sand, will have relatively large pores between its particles that allow water to enter and pass through the soil quickly. So if you have a soil composition that's mostly sand, remember our soil texture triangle, it is more likely that the water will pass through. Soil with a high percentage of fine particles, so that means most of the soil is composed of smaller particles like clay, there will be few or no spaces between the particles, which will then prevent the water from entering the ground. So remember, clay is very small, so if you have a lot of clay particles packed tightly, the water won't be able to pass through it. Almost acts like a sealant and won't let the water go. So we do need to know the difference between porosity and permeability. Porosity is just the percent of rock that contains pore spaces. So here on the left-hand side, we have a soil composition that has high porosity because there's a lot of space in between these particles where water could pass through. On the right, we have a low porosity because all of these rocks are super close together, or these particles, I should say, are super close together, and so there's not as much space for water to go through. Permeability, on the other hand, is the measure of the ability to transmit fluids, meaning the ability for water to run through. So if we have high porosity, we will also have high permeability because the water will be able to pass through quickly. On the opposite hand, if we have a low porosity, we will also have a low permeability because the water will not be able to pass through all of those small cracks and small crevices between the smaller particles. So sand would have a high porosity and a high permeability, and then clay would have a low porosity and a low permeability. Slope is another factor in surface runoff. So the steeper the slope, the faster the water flows, and the more likely you will be to get surface runoff. There's a greater potential for erosion on steeper slopes, which we talked about in our last unit, and then little water will actually be able to seep into the ground before it runs off on those steep slopes. So now that we've talked about the conditions that will influence surface water, let's talk about some examples of what surface water is. So remember, surface water is on top, so it's not below the ground. So anything that's on top of the surface will be surface water. So stream systems would be considered surface water. All streams will flow down slope to lower elevations, and then some will flow into lakes or oceans. Others will flow into streams and tributaries, and often tributaries will increase the size of a stream at its joining. So a large stream is just a river. So when we talk about rivers, they just tend to be really large streams. And then small streams are called brooks or creeks. So really, most of the smaller flowing current freshwaters are some type of stream. So a really large stream is going to be a river. A small one will be a brook and a creek. If you've ever heard of a babbling brook, it's just a very gentle stream that runs, typically through a forested area. Watersheds are another example of surface water, and a watershed is just all of the land area whose water drains into a stream system, and that is the watershed, or also called a drainage basin. We in particular are in the Catawba River Basin. We'll have a whole lesson on watersheds and river basins on their own, but we just need to be aware that a watershed is a part of surface water. Floodplains are also a part of surface water, so sometimes more water will pour into a stream than the banks of the stream channel can hold. So we can get flooding if streams happen to get higher than what their banks can hold. So a flood will occur when water spills over the sides of the stream's banks. The broad, flat area that extends out from a stream's bank and is covered by the excess water during the times of flooding is known as the floodplain. Okay, so the floodplain is just the area that is consistently flooded when a stream has excess water. It's a flat, typically a low-lying area, and sometimes houses will be built in floodplain areas because you can just kind of take the risk if you want to, if you're looking for land. But you have to be mindful because sometimes if you live in a floodplain, you do have to pay more for home insurance because you have to get flood insurance if you live in a floodplain. And then, of course, some things that we're probably familiar with, lakes, ponds, and reservoirs. So a lake is just water that collects in a natural depression in the surface of the land. So when we say natural depression, we just mean a hole, right? There's a large hole in the land and water naturally collects and it becomes a lake ecosystem. Most lakes will flow to rivers that will eventually flow to the ocean. So all water is connected and eventually leads to the ocean. Ponds are typically small and usually man-made lakes. So we have, when people build houses, sometimes they would like a pond and stock with fish so they can go fishing. And they will have, excavators come in and dig out a hole and fill it up with water and fish. But they're typically man-made. And they can help prevent flooding because of the natural banks that are created from the creation of those ponds. And then reservoirs are lakes that are specifically made for storing water, and typically they are stored behind a dam. So if you think of the Hoover Dam, there is a large containment of water behind it, which is the man-made lake, and then the dams can open and we can actually run that water and use it for hydroelectric power. So again, tying back to our previous content talking about renewable energy sources. Wetlands will also get their own lesson in this unit, but a wetland is a land area that's covered with water for a large part of the year. So that's basically things like bogs, marshes, and swamps. If you want to see a swamp in North Carolina, you would need to go to the coast because there are swamps in that area that are covered mostly with land or mostly with water as the tides go in and out. So the last thing we need to talk about today is just the difference between groundwater and surface water. We focused on surface water in this particular lesson, but tomorrow we're going to start with groundwater. So most of the precipitation that falls on land enters the ground through the process of infiltration and becomes groundwater. Groundwater will slowly move through the ground through percolation and eventually return to the surface through springs and then flow back to the oceans as surface water. Okay, so again, it's just a part of our natural hydrologic or water cycle. We just need to know the difference between the surface and the groundwater. So the surface water is on top and the groundwater is beneath. And we will focus on groundwater in our next few lessons, actually. So if you have any questions, let me know. And if not, I will see you guys in the next one.